So we're going to do a few examples from 13, which uses systems of equations to solve word problems or applications. Remember, systems of equations are more than one equation and more than one variable. And if we can use substitution or elimination. So we start with more than one equation. We've only actually looked at two so far. And more than one variable. This more than one equation, that's the system. More than one variable. The purpose of substitution and elimination is to get one equation and one variable that I can use to solve for that one variable, and then I can work my way backwards to find the second variable. So this first word problem we can look at. I'll just read it and then write down what I know. So a textbook store sold a combined total of 300 history books and sociology books in 1 week. So let's let X be the number of history books. I always like to write down what I know, even though it's right there in front of me. Write it down in my own handwriting. And I've got another variable. I will let that be the number of sociology books. And I know that combined, the bookstore sold 303 of those. So X plus Y equals 303. There's my first equation involving two variables. So I can't do anything yet. I need a little bit more information before I can actually go ahead and solve this. The next sentence says the number of history books sold. So the number of history books sold, X, was 2 times the number of sociology books sold. So there's my second equation. Now I have 2 equations, 2 variables. I can use substitution. I know what X is, so I can substitute 2y in here for X, because X is 2y. And now I have 3y equals 303. So y must be 101. If y is 101, then I can go back to that second equation and find out that x equals 2 times 101. So x must be 202. And we can double check to see that x, 202, plus y, 101, is in fact 303. So I had equation number 1 with 2 variables, and then I have to have a second equation in order to solve. So my answer is 200, x is 202, y is 101. So let's get another one. A little bit the same but different. The sum of 2 numbers is 49. So again, let x be one number. and y be the second number because we're dealing with two numbers. The sum of those two numbers is 49. So there's my first equation of two variables. I need another equation in order to solve it. The next sentence says the difference of those two numbers is 21. So there's my two equations, two variables and two equations. So I probably would solve this one, or we can use, actually, if we look at that, we can use elimination and add those two together, because that's going to eliminate the y variable. And it's going to give me 2x equals 70. So x must be 35. If x is 35, then I can go back to either one of those equations. 35 plus y equals 49. So subtract 35 from both sides. Y must be 14. So y is 14, x is 35. 35 plus 14 is 49. 35 minus 14 is 21. So define your variables. That's what I always do first. Then set up your equations. Then you could use elimination was the simplest here, but I could have used substitution. I could have let x equal y plus 21 and substituted it back in here for x. I would have got exactly the same answer. Okay, so let's see. Here's another one. A fruit company delivers its fruit in two types of boxes, large and small. So let's let X be large boxes. Y equals small boxes. So you could use L and S if you want to. Okay. A delivery of 3 large boxes. So this is the number of large boxes, the number of small boxes. A delivery of 3 large boxes. So 3x and 5 small boxes. So 5. So this is not the number. This is going to be weight. Sorry, my bad. Weight. Because they're giving us the number, we have to find the weight. 3 large boxes and 5 small boxes weighs 90 kilograms. So that's one equation. The second equation, a delivery of 9 large boxes and 7 small boxes weighs 216. So 9 large plus 7 small equals 216. So there's my 2 equations, 2 unknowns. Now I need to figure out a way to substitute for y or x or eliminate for y or x, because I've got 2 equations, 2 unknowns. I need 1 equation, 1 unknown. So how about if I multiply this top equation by a -3? So I'm going to make a third equation, which is number 1 times -3. And you're saying, why would I do that? Because that's going to give me minus 9x minus 15y equals minus 270. Okay, so now I'm going to add number 2 and 3 together. So this one is 1 times -3. When I add 1 plus 3, 2 plus 3, sorry, I eliminate the x's. So that gives me 0x minus 8y and 216 minus 270 is a minus 54. So I've eliminated my y. Now I have one equation, one variable unknown. Divide both sides by 8, which isn't going to be is -8, actually, as pretty as I had hoped. But that's going to be positive. 54 divided by 8. If you put that into your calculator, you get y is 6.75. Okay, so now I know what y is. Now I need to figure out what x is. So I need to go back to one of those equations, either the first one or the second one, doesn't matter, to find out what x is. So I'm just going to put it in the first. 3 times x plus 5 times 675 equals 90. 6 times 75, so I've got 3x plus 5 times 675 is 3375 equals 90. Subtract 3375 from both sides. 3x equals 90 minus 3375, which is 5625. And divide both sides by 3. X must be 18.75 kilograms, and this is kilograms. So the large boxes weigh 18.75, small boxes 6.75. So when you're dealing with equations of this form, ax plus by equals c, in this case, we were lucky that I only had to multiply one equation by a number to eliminate, add to eliminate. Sometimes you have to multiply both equations. We did that the other day. You had to multiply both equations by a number in order to eliminate a variable. A phone company, here's another example, offers 2 monthly plans. Plan A costs $20. So we'll just call this Plan A costs $20 plus an additional 7 minutes. So y equals plan and x equals minutes. So here's plan A. $20 plus an additional 7 cents per minute. So for every minute, you're going to pay an additional 7 cents. Plan B is no initial fee, but it costs 12 cents per minute. So the first question is, for how many minutes are the plans the same when y sub a equals y sub b? So I'm going to set them equal to each other. 20 plus 0.07x equals 0.12x. So then I would solve this for x, because I only have one variable. I just lost it. So 20 equals 0.05x. So x must be 20 divided by 0.05. So for 400 minutes, these two plans are the same. And I lost that problem. Let's see if I don't know what the next question is. What will the price be? This is when the 400 minutes, when they're the same. What will the price be at 400 minutes? I could put that 400 into either equation and come up with 0.12 times $448. I could check it with the other one, 0.07 times 400 plus 20 is $48. So at 400 minutes, they're going to have the same price. It's $48. Okay, now we need to do a 3 by 3. These get kind of yucky, but we'll start. We've already been given the equation. We have 3 equations, 3 variables. If I want to solve 3 variables, I have to have 3 equations. Here they are. So my goal is, I start with 3 equations, 3 variables. I'm going to use those same techniques that we've already talked about, substitution and elimination, to get 2 equations and 2 variables. Then I'm going to use substitution and or elimination to get 1 equation with 1 variable. And after I've got 1 equation with 1 variable, I can solve for that variable. I can figure out what that 1 variable is, and then I can go figure out what the second variable is, work backwards. The same thing here, after I get 1 variable, I can go find the other 2. So let's just work through this real quick. I'm gonna erase this because I need the room. Now I look at that second equation and it's already got just 1 variable. So I'm going to use it and divide both sides by a -3. So y equals 3. So that's helpful because now I know what y is. So now I can put y equal to 3 back into this equation, which will help me find out what z is. So 5 times 3 plus 3z equals -3. So this is 15 plus 3z equals -3. So subtract 15 from both sides. 3z equals -18. So z must be -6. Okay, so now I know y, and I know z, and now I can go back to that first equation and substitute a y equal to 3 and a z equal to -6. Then the only variable that's left unsolved is x. 5 times y is 3 plus 2 times -6. Z is -6 equals -3. Okay, so now the only thing I don't know is x. So let's see, that's 15. Let's subtract 15 from both sides, and let's add 12 to both sides. If I do that, then I'm left with negative 2x equals minus 3 minus 3 minus 6. So then x must be, divide both sides by negative 2, 3. So there's the solution, and you can write it as a triplet, ordered triplet. X is 3, y is 3, z is negative 6. That's the ordered triplet x, y, z that will solve all 3 of those equations. And we started with this equation because it really only had one variable. So that made things a little bit easier for us. What if I have an equation or a series system of equations that I don't have one of my variables already solved? That one was nice. This one's not going to be as nice, but let's figure out what to do. So there's an x, y, and a z. Here's a 2x minus 2y plus z equals 4. Here's a x minus y plus 2z equals 5. So remember, I have 3 variables, 3 equations. Somehow I want to eliminate or substitute. I'm going to eliminate and get myself 2 equations with 2 variables unknown. So if I add the first one and the second one, maybe it'd be helpful if you want to number these. 1 plus 2. We're going to add those 2 together. And what's that going to give us? That's going to give us 3x. The y's are eliminated, plus 2z equals 1, just by adding number 1 and number 2. The y's drop out. So here's the tricky part. I need to get another equation with x and z. So if I multiply number 3 by 2, so then I'm going to get 2x minus 2y plus 4z equals 10. And then I can add, we'll just call this 3a. If I add 1 plus 3a, again, I'm going to eliminate the y. So x plus 2x is 3x. Plus 2x is 3x. 2y minus 2y is 0. Z plus 4z is 5z. And then I've got negative 3 plus 10 equals 7. So now I have 2 equations with 2 variables, an x and a z. So now I need to get to 1 equation, 1 variable. So I'm going to multiply this one by negative. I'm going to make that negative and that negative and that negative. And I can do that as long as I do it to both sides of the equal sign. Now I'm going to add these 2 together. So I get 0x minus 3z equals minus 6. So z must be 2. Okay, if I know that z is 2, I can put that into one of these equations and find out what x is. 3x plus 2 times z, which is 2, equals 1. So 3x minus 4 equals a negative 3. So x must be a negative 1. So now I know what z is and I know what x is. I can go back to any one of those equations. I'm just going to go back to, the equation number 3. This one. Negative 1 minus y plus 2 times 2 equals 5. And this is 4 minus 1, so 3. So I'm going to subtract 3 from both sides. And so I get the negative y equals 2. So y must be negative 2. So there's my answer. X is negative 1, y is negative 2, z is positive 2. That is the ordered triplet. And if I put x, y, z into any one of these equations, I will get a true statement. If I put an x equal to negative 1, a y equal to negative 2, and a z equals to 2, all three of those will be true. So here's another 3 by 3. Y plus 4z equals, well, I say it's a 3 by 3. It's not really, but it's 3 equations, 3 variables. I guess I could call it 3 by 3 if I put in 0x. And the next equation is minus x plus 2y minus 2z equals negative 9. And then I get a 2x minus 4y plus z equals 15. This first equation, I can solve y equals 2 minus 2 minus 4z. So then I can put that into both of these next equations. 4y. Y is 2 minus 4z. So minus x plus 2 times y, which is 2 minus 4z, minus 2z equals negative 9. 2 times x minus 4 times y, which is 2 minus 4z, minus 2z equals 15. So now I need to simplify these. I'm going to come over here with this one. Negative x plus 4 minus 8z minus 2z equals negative 9. So that gives me a negative 10z here. And so I have minus x minus 10z, and subtract 4 from both sides, equals minus 13. I could solve that for x. Minus x, add 10z to both sides, equals 10z minus 13. Multiply both sides by negative x equals negative 10z plus 13. Now, there's x in terms of z. So what I could do is I could go back to this one and substitute a z in for x. That way, the only variable that I'm going to have in that whole equation is z. So let's do that. 2 times negative 10z plus 13 minus, let's distribute that parentheses, 8 plus 16z minus 2z equals 15. That's minus 20z plus 26 minus 8 plus 16z minus 2z equals 15. Now I want to get everything with a z on one side of the equal sign and everything that doesn't have a z on the other side. So what do I have? A 26 minus 8, which is 18. So let's subtract 18 from both sides. And then I have a minus 20 plus 20z plus 16z, which is a minus 4z minus a 2z, so minus 6z. Oops, I messed something up, didn't I? Oh, I wrote this one down wrong. That should just be not 2z. Copy that problem down wrong. Okay. Minus 8 minus z. So there we go. Now I have minus 20z plus 16z is minus 4z. Oh man, I really messed this up. Plus also supposed to be plus z. Let me try that again. Minus 20z plus 16 is minus 4z plus 1z is a minus 3z equals a minus 3. So z must be 1. All right, now I got to work backwards. If z is 1, let's go back up here and find out what y is. 2 minus 4 times 1 equals negative 2. Y is negative 2. If z is 1 and y is negative 2, then I can go back into either one of these other equations. How about this one, where I've solved for x? X equals negative 10 times 1, because z is 1, plus 13. Negative 10 plus 3, 13 equals 3. So x must be 3. Now with these systems, you're going to have to make sure you leave yourself a lot of room, because x equals 3, y equals negative 2, z equals 1. There's my final answer. It takes a lot of room, so give yourself a full page of paper. So there's a system of 3 equations, 3 unknowns. Identifying solutions. Well, this first inequality is just x is greater than negative 4. And then they give you a bunch of ordered pairs. 4, negative 1. Is x greater than negative 4? Yes, x is positive 4. So yes. What about negative 8, negative 4? Is x greater than negative 4? No. What about -4, 3? Is x greater than -4? Equal to -4, but it's not greater than. And -5, 6. Is x greater than -4? No. So the only order pair in that whole set that's actually greater than -4 is that first one. Okay, so that was an easy one because it only had an x involved. What if I actually have a y and an x? Y is less than 6x plus 5, and they give us some ordered pairs. So the first ordered pair they give us is 6, 40. So you plug in 40 for y, and you get less than 6 times 6 plus 5. So this is 36, this is 41. Is 40 less than 41? Yes, it is. So that one's true. What about this ordered pair? 4, 32. So y is 32. Is it less than 6 times 4 plus 5? I'm going back to that original inequality. Is 32 less than 24 plus 5, 29? No. What about -2, -5? So I plug in a -5 for y. Is y less than 6 times -2 plus 5? Is y less than -5 less than -12 plus 5? Is -5 less than -7? No. So out of those ordered pairs, that's the only one that's less than, I can say, satisfies that inequality. So how do I graph y is less than or equal to 3? So it doesn't tell us anything about x. It just says whatever x is, it has to be below this line, which is y equal to 3, and everything below it. That's how I would graph this inequality. At every point below this line, y equal to 3, including the line. And that's why it's a solid line, not a dotted line. Y less than -1. So here's -1. Y this time, because it's not including -1, it's going to be everything below it except for that line. So it's everything below y equals -1. What about greater than y greater than 5 or -5? Here's -5, 1, 2, 3, 4, 5. This one's going to be dotted because it's not equal. It's everything above that line, not including the line. Vertical either. There we go. What about x is greater than or equal to -1? So now I'm talking about x. Here's -1x. Here's the line, x equal -1. That's this line right here. This is my x coordinate. This is my x coordinate. This is my y coordinate. What this is saying is I want all values of x, including -1, that are greater than. So it's going to be everything this way. Everything to the right of -1. What about x greater than 6? Well, 1, 2, 3, 4, 5, 6. Here's the line y equals 6, x equals 6, sorry. And it wants everything greater than, I'm going to make this a solid line because I already everything greater than 6. So all values of x that are greater than 6. So that's how you graph an inequality. What about this inequality? Y is greater than 1/3 x plus 1. So the first thing I have to do is graph the line. So if this was an equal sign, this is the slope, this is the y-intercept. So this line crosses the y-axis at 1. It has a slope of positive, so up 1 over 1, 2, 3, up 1 over 2, 3. So there's that line. Okay, so we want all values of y that are above that line or greater than that line. And actually, I'm not including the line, so this should be dotted or dashed, not solid. Dash line, because I'm not including the line. I just want values greater than that line. Okay, so pick this value. This is a 2. Why? Is 2 greater than or equal to 1/3 times 0 plus 1? Is 2 greater than 1? Yes. So this point right here is in the solution set. And in fact, every point above that line will satisfy this inequality. What about 0, 0? Is 0 greater than 0 plus 1? No. That's why this below the line is not the solution set. So this is the answer to this equation. Everything above that line, not including the line, will satisfy. So let's do another line. Y greater than negative 4x plus 3. Graph that line. It crosses the y-axis at 3. That's the intercept, but it has a slope of negative 4 over 1. So I'm going to go down 1, 2, 3, 4, and over 1. Negative slope. So, oh my gosh, I missed it completely, didn't I? So there's my line going through those 2 points. And I missed it again. Darn it. Struggling here. Maybe need a ruler. That's a little better, but not much. Okay. So there's my line. And again, it's going to be dotted because I didn't include, it's not greater than or equal to, it's just greater than. So what values are going to satisfy this inequality? So I usually just pick 0, 0 and ask myself, is 0 greater than negative 4 times 0, which is 0 plus 3? No, it's not. That means that this point is not in the solution set, so everything on the other side must be. So there's the solution set to that linear inequality. Add another linear inequality. Y is less than or equal to 2x minus 5. Graph it on the same graph. So there's 1, 2, 3, 4, 5. There's that crosses the y-axis at negative 5, 1, 2, 3, 4, 5. And it has a slope of 2 over 1. So I'm going to go up 1, 2 over 1. So here is this line, and I'm going to make, this time I can make it solid because it does include the line. So there it is. But now I need to figure out what's the solution to the inequality. It goes on and on forever here, but I want all values of y that are less than 2x minus 5. So again, if I put 0, is 0 less than or equal to 0 minus 5? Is 0 less than or equal to negative 5? No. So that means that 0, 0, which is the origin, is not in this solution set either. So this solution set is everything below this line, including this line. So the solution set of the first line is everything to the right of the dotted line. The solution set to this line, including the line, is everything below it. Now, what I need to notice is where in this graph did I color both of them? Well, this area is just satisfies the first one. This area down here just satisfies the second one. But this area right here, I wonder if I can get fancy and maybe find another color. This area, maybe not. One tool. Here is satisfies both of those equations. Everything, including the line, not this line that stays dotted, but everything over here is going to satisfy both equations. So this is my answer. Not this line, and everything to the right of it, where I colored in twice. So that's the solution when you're asked to find the solution of a system of linear inequalities. You're going to have an area on a graph. So any point that I choose in this area, if I pick a 6, 0, I can put it back into either one of those inequalities. Is 0 greater than negative 4 times 6 plus 3? Is 0 greater than, that's negative 24, negative 21? Yes. It's also going to satisfy this one. Is 0 less than or equal to negative 2 times 6 minus 5? What did I do? Is 0 less than negative 12 minus 5? Did I do that one wrong? Yeah. Negative 0 less than or equal to negative 17. Clearly, I did. Oh, this is not negative 2. This is positive 2. Oh, that's what I did wrong. This is not negative 2. Is 0 less than or equal to 2 times 6, which is 12, minus 5? Yes, it is. Sorry about that, but my sloppy handwriting. Yes, it's true. So this point, 6, 0 satisfies both of these inequalities if I make sure I get the right problem and not a negative sign. So the shaded area is the solution set. and you have to describe it with a picture. I think that should take you through examples for week 13. Hopefully, that was helpful. I'm going to wrap it up and make it available